now that you have your packages all installed, I'm going to tell you a little bit more. So that was just kind of an intro video. So R is a really powerful language used for statistical modeling and programming, but it can also be used for a lot of other things. These tutorials are going to show how to use R for the social sciences. So specifically about me, I am a developmental psychologist, so I am trained in primarily regression and ANOVA-based analyses. So I'm going to be showing you some useful tools and tricks for data cleaning that I use as a social scientist and as a graduate student and as a researcher that may be applicable to you if you are in a psychology department, a sociology department, a human development and family science department, maybe marriage and family therapy, social work, that branch of social science. What I'm talking about here may be helpful to you. So in the last video, we installed all of these packages. In this video, we are going to be using these packages. So I'm just going to come here and click Run and get all of my libraries set up. That's just what I do when I sit down at a new environment and I want to start coding. I just know that these are the ones that I'm typically using, so I just load them all and move forward from there. So there are a few different ways that you can code and type. My preferred way of coding is to create these markdown files and create some comments and then have a chunk that I can just insert an R chunk just by doing that, and it inserts a chunk of code. That I feel like makes my code the most readable, but it's not the best way for learning. The best way for learning is for you to type it out. We could just go through this whole tutorial and have me just click on these things, but I don't think that's going to be as helpful to you as me actually typing them out. So I'm going to cover up that, and I'm going to ask you to type with me so that we can learn together. And I apologize that it's kind of down on the bottom of the screen. Maybe by the next video I'll try and fix that. So if you have questions about any of the packages or anything in R, you can do a question mark and then type in what you want to know. So if we wanted to ask questions about read CSV, we could do that. And now it pulls this over here. It pulls up some documentation that you can read. It's kind of like asking help in Stata or Googling it, because this is what will come up when you Google read CSV. So there's also, you can put in 2 question marks, and that does something else. I'm not exactly sure what the difference is. I'm not an expert on all the nuances of R. So sometimes it works with 1, sometimes it works for 2. If you try 1 and it doesn't pull it up what you want, try the other one. In this case, 1 question mark is what we want it to do. So let's first pull in some of our data. That's probably the most important part, and I always tell people that if you can get your data and your packages and everything set up in R, you're like halfway done with your analysis. Just getting your environment set up can take some time, and it can be a fun endeavor. So I'll show you how to import something from Stata. So you have to pull in the library tidyverse, and it's probably already imported, especially if you followed my advice and already imported all of your libraries, but I just want to show you this is where the tidyverse comes from. And then I'm going to call it whatever. So I'm going to be pulling in the icecream.dta from a Stata data file. Okay, so this is the one I'm pulling in, and I have to tell R where I want it to look for my files. So I'm going to go set working directory. That's set WD, and then in parentheses you're going to put the path to the file. So I come to where my files are. Maybe I have to close that out. Come up here, right click, copy, set wd in parentheses and in quotes, put this. Now Windows is kind of weird that it gives the wrong one here, so you actually have to switch that to a / rather than a backslash. And again, your path may be different than mine, it's just wherever you chose to save it. So now I have a different working directory, and if I come over here to Files, More, go to Working Directory, it now shows me all of my files here that are over here. So that's an important thing to know in R is that set working directory tells R where to look for your files. So then when I want to pull in a data set, I don't have to give this whole path. I can just give the name of the file and it'll find it for me. So when pulling in a file, there's a few different types of your command. The first part is whatever name you want to give it. So I'm going to name mine ice cream. Okay, and then you have to do the assign, which it could be in equals, but in R it's not. It's the less than sign and then the dash. So ice cream assign, and now I'm going to go into tidyverse and access something that's called Haven, and then 2 colons, and then read DTA. And because I see it here, I can actually just click on that or push enter, and it would have worked. So I'm going to then put the name of that file, the DTA file that I'm trying to import. I'm going to type it out here, ice cream.dta, and press enter. Now I have this up here in my data. So it's now pulled in. If I double click or just single click on that, it pulls up my entire data file. So I've got 33 people, and this is fake data, by the way, so there's no IRB here. Fake data and 4 columns. Then these are my variable names that I wanted to pull in. So that's how you pull in a Stata data file. Now you can do an SPSS file the same way. We'll call the SPSS file exam. So again, that's my name that I am giving it, assign, Haven, : read. I'll come down to SPSS and press enter, and then come over here and grab my SPSS file, which is examinations.save. Again, put it in quotes. It's case sensitive, so make sure you grab it right there. Now exam is up here, and it pulled it in correctly. So that's Stata, that's SPSS. Now let's go for CSV. So CSV is a simpler form. It doesn't have to pull it in any weird way from Stata or SPSS. So a CSV, you can just use an R function rather than having to use this thing and tell it where to look for the function. You can just give it a name, so I'm going to give it flavor, assign, read.csv, file equals the name of my file, so I'll give it flavor2.csv, and then header equals false, and separator equals a comma, because it's a CSV comma separated file. Oops, I said flavor rather than flavor2. So I messed up. I'm going to click up on my keyboard and it pulls it back up. And I'm going to put in flavor2 and put it in. So I put in header equals false because, let me show you this. Header equals false means that the first line is data. If I had something like this that was name, age, gender, or whatever nope, I don't think that's what it is, favorite and gender, then I would put header equals true in my file because the first name are the first row are the variable names rather than data. So that's the difference between header equals true and header equals false there. But because my file didn't have anything, it had data on the first line, I put header equals false, and that pulled it in. Now you notice that now it gave it variable names that aren't very helpful, and we'll fix that later. So I'm going to make sure that I got all the data that I might need now that I've shown you how to do it. I'm going to come here, and as you can see, here's ice cream. It shows it to you, but we didn't pull in relationship, so I'm going to run this again and pull it in. That will overwrite the ice cream that I already had. So if I had done any changes to ice cream, it would be overwritten. We pulled in examinations, we pulled in flavor 2, and R also provides some free data files, and one of them is empty cars, and a lot of my examples use that, so I'm going to pull that in just in case. But if you wanted to pull that one in, you could just say data empty cars and then run it, and that does the same thing. This head says show me the first 6 observations of it just to confirm that it looks right. And in the next video, I'll show you some data cleaning and data manipulation that you can do in R.